Let's look at some qualitative graphs here, okay? So this is a position time graph. So what we have to think about is we have to think about the slope, okay? The slope of this line is the velocity, and the velocity is the easiest thing to visualize, okay? So notice that from 0 to 5 seconds, the slope is constant, okay? So this means we're moving at a constant speed. In fact, we could find this slope, right? It's, we went 2 meters in 5 seconds, right? So for this entire time, we went 0.4 meters per second. Not super fast, right? Okay. So that's a constant velocity right there from 0 to 5. The slope does not change. And then we speed up, right? And it doesn't take us any time to speed up. We speed up instantaneously. So this means that, by the way, real graphs can't do this, right? You can't speed up instantaneously. That would be like an infinite acceleration, okay? And for this segment here, we go 3 meters in 3 seconds. So our velocity is 1 meter per second. Okay, I know we're not being qualitative here, but I just want to point out, right? So this is a slower velocity, and this is a faster velocity. We're going slow, then we go fast, okay? And we instantaneously change. So this could happen if you were like driving 20 miles per hour in front of the school, and a giant truck came up behind you with, hopefully with like a kind of like a plasticine clay on its bumper, and you just stuck to their bumper and suddenly started going their speed. Of course, this part would kind of hurt, right? That would be a very large acceleration. Probably set off your airbags, okay? But anyway, that's what's going on here. So when we look at these graphs, we got to think about the slope, okay? Let's look at another one here. Ooh, all right. So what's going on here is that, remember, the slope is the velocity, right? Okay, so let's think about that, right? Here we've got a positive slope. Here we've got the slope is 0. Okay, so we're moving. In fact, we're moving at almost 1 meter per second. Okay, almost exactly, right? Maybe it's just like a little higher, a little lower, or something like that, right? And then suddenly we're not moving, right? So this is like one of those Volvo commercials where they crash into a wall, right? Moving, not moving, right? The wall is at 5 meters. You move, but you can't get through the wall. Okay, there it is, right? Moving, stopping. This hurts here, right? Anytime you see a sharp corner on a position time graph, it's probably not real, right? It implies like you change velocity instantaneously, which would be an infinite acceleration or something like that. Okay, so let's look at some other more realistic graphs, okay? And this is a familiar graph. So what's happening here, remember that the slope is the velocity, right? Okay. The slope of this thing is the velocity. Now, if you look at this, at the beginning here, the slope is small. This is a small slope, right? It's like, okay, if we drew a tangent line here, right? I'll show you this in the whiteboard videos. I'll show you the slopes of those, right? Okay, but here we've got a small slope. Here we've got a moderate slope. Here we've got a high slope, right? So what's happening here is our velocity is getting more and more positive, right? The velocity is increasing because the slope is increasing, right? It's like climbing Mount Hood or climbing Mount Adams, right? As you get up to the top, it gets steeper and steeper. Okay, so the velocity is increasing. This, by the way, is a positive acceleration. Okay, we've got a small positive velocity, a moderate positive velocity, a high positive velocity. Slope. I always forget to put the E on slope, and then it's like slop. Okay, so this is just a positive acceleration. Of course, we've seen this on our moving plots lab by now, right? Ooh, what's going on here? Well, this is interesting, right? You know, let's look at that. Okay, here we've got a high slope. So therefore, we're moving fast, right? And now we're still moving in the positive direction, right? This still has a positive slope. It's going up as time goes on, right? Okay, but this is a small slope. So this is therefore a small velocity, right? We're going slow. Well, if you go from fast in the positive direction to slow in the positive direction, that's a negative acceleration. Okay? This is a negative acceleration. Now, let me just show you a cool thing about these two graphs. Okay? Do you see how this, we can talk about concavity. Okay? See how this is like a cave? Not really, right? But it's like a depression. This thing is concave. Notice that we get to the cave part of it from below. Just bear with me, okay? This is how my math teacher explained it to me. This is like a cave, right? We're going into this cave, only, it's not a very deep cave. It's more of like a depression, right? Okay, and we get to it from below. So this means that it's a negative acceleration. This, by the way, is called negative concavity. If you can get to the cave from below, then it's a negative acceleration somehow, right? And the reason it is that we're going fast, and then we slow down. All these velocities are positive, and so if you slow down while moving in the positive direction, that's a negative acceleration. Let's go back to the previous one. Notice that now we get to the cave from above, right? We get to that cave from above. I know it's not really a cave, just bear with me. Right? We get to the cave from above, so this is positively concave. Positively concave is positive acceleration. Okay? Negatively concave is negative acceleration. This is negative concavity. Negative acceleration. Okay? So this is going to be helpful, right? So we can identify accelerations. If we see a curve and we can get at the cave from below, we know that it's negative acceleration. We can figure out why, right? And we know that if we can get to the cave from above, okay, then we know that this is somehow a positive acceleration, okay? All right, so let's look at some more. Let's try. Ooh, okay. So first off, which way do we get to the cave from? Do we get at it from below? See, that looks convex to me. It doesn't look concave, right? I see the concave side from above, right? Concave means it's sort of like a cave, right? So this is somehow a positive acceleration, right? But what's weird here is that all these slopes are negative. So let's think about what's going on here, okay? So look at this. This is steep, but negative, right? So this is a large negative velocity. Right? And then here, there's no slope, right? The slope is 0. So what happened was we were moving in the negative direction and we stopped. We were moving in the negative direction and we stopped moving. Well, remember, if you've got a negative velocity and you want to stop, you have to have a positive acceleration, okay? That means you're going slower and slower. Okay, a negative velocity and you have a positive acceleration, right? If they're in opposite directions, the rule is that you're going slower and slower. So that's what's going on here. But we knew just by looking at the graph that somehow it was a positive acceleration, okay? All right, let's look at another one here. Which way do we get to the cave on this one? Do we get to it from above? No, it looks convex from above, right? Okay. We get to it from below. So somehow this is negative acceleration. Let's figure out why it's negative acceleration. Okay, so here our velocity is 0 because our slope is essentially 0. Somewhere in here, right, it's 0, like here. Okay, here it's actually slightly positive, okay? Okay, so right here the velocity is 0. Here the velocity is negative. It is fast, right, because it's a steep slope and it's negative velocity, right? It's going down. Okay, so this is just basically I'm sitting still and I start to go in the negative direction, right? So I have a negative velocity and I have a negative acceleration, right? If I have a negative velocity and a negative acceleration, that means I'm going faster and faster because they're in the same direction. Okay, but I'm going in the negative direction. So notice this, right? Not moving. Moving. I'm going faster and faster, and I'm going in the negative direction. Therefore, it's a negative acceleration. All right. Let's look at another one. Ooh, which way do we get to the concave for this guy? Well, not from above. This is definitely negatively concave, right? So it's therefore a negative acceleration. But how? Let's think about this, right? Here we've got a steep positive velocity, right? So this is positive velocity, a big one, right? Here we have less positive. Here it's 0, right? So it goes from positive to 0, right? Because this slope right here is this slope right here. I could draw it. Draw a tangent line there, right? That slope is 0. And now we go to negative velocity. Okay? We're going to actually look at a graph like this. An actual thing is going to do this, right? So you've got positive velocity. We've got negative velocity here. Okay? So we went from positive to negative. Okay? So this means that this is definitely a negative acceleration. Okay? If you have a positive, let's look at this first segment here, right? Okay, you have a positive velocity, right? And a negative acceleration. You're going to slow down, right? Now, if we go to the right of this line here, now we've got a negative velocity and a negative acceleration. And notice that now it gets, after this time, it gets steeper and steeper, right? It's going faster and faster. Okay? So this is negative acceleration the whole time, which is kind of cool. All right, let's look at another one here. Ooh! And I always ask the kids, I go, is this upwardly or downwardly concave? You got an answer for that? Is it positive or negative concavity? And the answer is both. Let's divide the graph about here. Here it's positively concave. So therefore it's a positive acceleration somehow. And here it's negatively concave. So this is a negative acceleration. Right? So for this region from 0 to 4.4 seconds or whatever that is, right? By the way, this point is called an inflection point. Inflection point. It's an inflection point. Okay. So for this first part here, right, it's getting steeper and steeper. We've got a positive velocity and a positive acceleration. Okay? And if you have that, you're going faster, right? So it gets steeper and steeper, going faster and faster. Now we've got this whole thing has a positive slope. So we have for here we've got a positive velocity, but a negative acceleration. And so we go from fast to slow. All of these slopes, except for maybe you could argue that last little bit there is positive. Okay, maybe this little bit here too. Okay, so here we go fast. We go from slow to fast to slow. This is like you in stop and go traffic, right? You speed up, you move, you slow down, and you stop. You speed up, you go some speed, you slow down, you stop, right? All right, let's look at another one. I like this one. Is this positively concave or negatively concave? Well, it's both. Where's the inflection point? See if you can find it. I think it's like right about here. By the way, the line is nice and straight at an inflection point, okay? The line is nice and straight at an inflection point. It's the part where it's like goes from curving this way to curving this way. So this is negatively concave. So this is a negative acceleration. By the way, this is just the opposite of that last graph, right? Negative acceleration. This is positively concave. So this is a positive acceleration, but why? Let's think about this, right? So here we're going fast in the positive direction, right? We have a big positive slope, right? And then suddenly we've got 0 slope here, right? Velocity is 0. So this is, I'm moving, I slow down, I stop, okay? So if we have a positive velocity and a negative acceleration, that's how you slow down, right? Remember, when these are in opposite directions, you slow down, right? So then I slow, okay? Now, in here, right, from here to here, I still have that positive velocity, and I've got that negative here I've got the negative velocity, right? And I still have a negative acceleration. So I actually go faster and faster for a little bit here, right? Okay, so from here to here, these guys are in the same direction. So I speed up a little bit, right? I speed up a little bit, and then suddenly here I have a negative velocity. Okay, but here, from here on, right, we say that we have a positive acceleration, right? So if you have a negative velocity and a positive acceleration from here to here, we can look at this, right? From this little part here, okay, I've got a negative velocity, positive acceleration. That means I'm going to slow down because these guys are in opposite directions, right? This is the most complicated one of all, right? And then from here to here, if we look at this, now we've got a positive velocity and a positive acceleration, right? From here to here, the whole thing is positive, right? I have a positive velocity, a positive acceleration, so therefore it speeds up, right? And you can see it's getting steeper and steeper, right? It goes from zero slope to steeper, right? Here it goes from negative slope to zero, and then it goes from zero to positive, okay? That's the most complicated one. All right, in the next video, I'm going to show you some of these slopes. We'll look at the sort of the characteristic graphs that we need to learn. See if you can figure out what's going on with the slopes, okay?